MOSFET biasing circuit analysis. Here we consider N-channel depletion-type MOSFET. Here is general biasing circuit. We have VDD, and here ground, RG1, RG2, RD, and RS. This is MOSFET. The Matlab code is the same for N-channel enhancement type and N-channel depletion type. Here we list Matlab code here. This is page 1 of the Matlab code. And this page 1, the bottom part code. Here is page 2, the upper part of the code. And here is page 2, bottom part of the code. And here's page 3, upper part of the code. And here's 3, bottom part of the code. Find the bias levels for the circuits in the figure. Note that to bias a D MOSFET in the enhancement region, we usually use a voltage divider at the gate. Here's voltage divider at the gate. And this MOSFET is depletion type MOSFET. From this figure, we have DSS equal to 10 milliamp and VGS off equal to -5 volts. And RG1 equal 230 kilo ohm, RG2 is 20 kilo ohm, RD is 1 kilo ohm, RS is 100 kilo ohm. And this MOSFET is depletion type MOSFET. Solutions. From the figure, we found out VT threshold voltage is -5 volts. IDSS equal 10 milliamp. From these two values, we can find Kn. Kn equal to IDSS divided by VT square. In this case, IDSS is 10 milliamp. VT equal to -5 square equal to 0.4 milliamp per volt square. And we need to change to amp per volt square, so equal to 0.4 times 10 to the -3 amp per volt square. And resistors RG1 230 kilo ohm, we change to ohm, 230,000 ohm. RG2 is 20k, we change to ohm equal 20,000 ohm. RD is 1K equal 1000 ohm, RS 100 ohm, and VDD equal 25 volts. To solve this problem, we need input the quantities into Matlab code. Here we have VDD equal 25 volts, VT equals -5, Kn equal 0.4 times 10 to the minus 3. RG1 in ohm equal 230,000. RG2 equal 20000. RD equal 1000 and RS equal to 100. When we input all these quantities, we get the answer as follows. The MOSFET is operated in saturation region. VGS equal to 0.7 volts. The drain current ID equal to 12.997 milliamp. The drain source voltage VDS is 10.7 volts. Analyze the circuit in figure to determine ID and VD. The depletion MOSFET has VT equal to -1 volt and Kn is 0.5 milliamp per volt square. And here is the circuit. Solutions. Here in the circuit, we do not have RG1. It is open circuit, so we take RG1 equal to infinite. In Matlab code, we take RG1 equal to 1 times 10 to the 38. And RG2 equal 10 mega ohm equal 10 times 10 to the 6 ohm. RD equal 32 kilo ohm equal 32,000 ohm. RS equal to 4 kilo ohm equal to 4,000 ohm. VDD equal 10 volts. VT equal to -1 volts. Kn equal to 0.5 milliamp per volt square. We need to change to SI unit equal 0.0005 amp per volt square. All we need to do, we need input all these parameters in the Matlab code. Here is input in the Matlab code. VDD equal 10 volts, VT equals -1 volt, Kn equal 0.0005. RG1 equal to 1 times 10 to the 38. RG2 equal 10 times 10 to the 6. RD equal 32,000. RS equal to 4,000. The Matlab gave us the output as here. VGS equal 0.5 volt. The drain current equal 0.125 milliamp. Now, to find VD, we need to do the calculations. $10 volts minus VD equal to ID times 32 kilo ohm. Here is schematic. We have 10 volts at here, and we need to find VD. According to Ohm's law, 10 volts minus VD equal to current ID times resistance, 32 kilo ohm. So from this equation, we can find VD equal 10 volts minus ID times 32 kilo ohm equal 10 volts minus 0.125 times 10 to the minus 3 amp times 32 times 10 to the 3 ohm equal 10 volts minus 0.125 times 32 volts equal to 6 volts. Example: find bias levels for the circuit shown in the figure. This figure is transfer curve for ID versus VGS. From this figure, we have IDSS equal 20 milliamp and VGS off equal to minus 5 volts. The circuit is the circuit. We have RG and RD and RS. VDD equals 15 volts. Solutions. From ADSS equal 20 milliamp, we can find Kn. Kn equal to ADSS divided by VT square. So ADS 20 milliamp, VT equals minus 5 volts square. So we get 0.8 milliamp per volt square, and we need to change to SI unit, 0.8 times 10 to the minus 3. And VT equals minus 5, VDD equals 15 volts. RG1 equal to infinite. So here is open circuit. We take RG1 is infinite. So in Matlab code, we take RG1 as 1 times 10 to the 38. RG2 equal to 100 kilo ohm equal to 100,000 ohm. RD equal 3 kilo ohm is 3000 ohm. RS equal 1 kilo ohm is 1000 ohm. Input parameters we have before. So VDD equals 15 volts, VT equals minus 5, Kn equals 0.8 times 10 to the minus 3. So RG1 equals 1 times 10 to the 38. RG2 equal to 100,000. RD equal to 3000. RS equal 1000. Here we get the answer. VGS equal to minus 3 volts. The drain current equal 3.048 milliamp. And drain source voltage VDS equal 2.8 volts. For the following bias circuit, find VGS, ID, and VDS. And given VT threshold voltage minus 3 volts, Kn equal to 100 microamp divided by V square. So solutions. We have VDD equal 10 volts, RG1 is infinite, RG2 equal 0. So we know that VG equal to 0 volts. So VG is 0 volts. It's connected to ground. RD equals 0 ohm. There's no resistor, so RD equal to 0 ohm. RS equal 20 kilo ohm equal 200,000 ohm. VT equals minus 3 volts. So we input all these parameters in the Matlab code as follows. So VDD equals 10, VT equals -3, Kn equals 0.1 times 10 to the -3, RG1 equals 1 times 10 to the 38, RG2 equals 0, RD equals 0, RS equals 20000, VG equals 0 volts. The answer is VGS minus 2. The drain current ID equal to 0.1 milliamp, and drain source voltage VDS equal 8 volts.